Hi guys, Sam Atkinson here from Core Java Interview Questions, and I just want to thank you for checking out the course, Movie Store Interview Questions solved using TDD. Now, this is going to be a really good course, relatively brief, maybe about an hour or so, where we're going to do a deep dive into this Movie Store interview question. Now, this is an interview question that I have used when interviewing candidates in the past, so you're getting real experience with a proper interview question. We're going to be solving it using test-driven development, and I'm going to be teaching you how to use TDD along the way. Now, I love TDD, I'm a huge fan of it, and I'm sure you're going to be after this. And so we're going to start off with an introduction into what test-driven development is, and then we're going to dive straight into the code, because I think this is best taught hands-on. The main cycle for test-driven development is this three-point triangle: red, green, refactor. We're going to use these terms a lot. Red is writing a failing test. So you write the test, you run it, you make sure it goes red. That's important. You have to make sure you've run it, you have to make sure that it fails and it fails correctly. Green is then making that test pass. So again, you write the code, you run the test, you make sure it goes green. Refactor, if the code you've written is perhaps messy, which is totally fine because the aim of the green section is just to make the test pass. If you need to refactor it, you can do that in this section. And once you've refactored, you need to make sure that you run the tests again. For the first part, for the red, you need to make sure you test the simplest thing you can each time. So this is how we build up functionality. We test the most basic piece of functionality we can. We make that test pass. We then test the next most simplest thing you can. By doing this, we ensure that we build up a really comprehensive test suite. The simplest thing that you can test is genuinely, when you start out, was probably going to be a null test. So you're testing that nothing happens when you use the code base. This might sound quite strange at the moment, but this is the first test we're going to write as part of Movie Store, so don't worry about it too much. You'll see when we get into the code base. Once you have your failing test, you then need to write the simplest code that you can to make the test pass. So that means nothing too complicated. This means not implementing the full solution. You have to implement the most basic thing so that the test will go green. If that means hard coding a return result, then awesome, your test has passed. That means you need to write more tests to force you to get the correct functionality and ensure that you've got a full test suite of coverage. And that, for me, is really important. The reason why TDD is brilliant is because by writing the simplest code to make each test pass, you have to ensure that you have everything tested to have resulted in the correct code for your solution. Once you have that green test, if your code quality can be improved, you can refactor it. And by code quality, that means perhaps if your tests you have duplicate data, you can refactor that to be, a single setup method. It means, if you've put some really horrible code in to get it working that you could probably make a bit cleaner, you can absolutely do that. The one thing that is really important here is you only refactor the test code or the production code. You can't do both. The test code is used to ensure that the production code remains functionally the same. So if you're refactoring the production code, leave the tests alone, because that way you can ensure the tests go green, the functionality is still correct. If you want to refactor the tests, you leave the production code alone because you know the production code is green at the moment. Do not refactor both at the same time. It's really important. So that's kind of a really high-level overview of test-driven development. We're going to dive straight into the code because I think that's the best way of learning about this. Okay guys, we're going to get straight on with doing some code. For the entirety of this course, I'm going to be using IntelliJ IDE. IntelliJ is absolutely brilliant. I've used it exclusively for about 7 years and I cannot recommend it to you enough. So there's a link somewhere on this page for you to go and get it. I highly recommend you go and download it. You're welcome to use NetBeans or Eclipse if you want to, but I'm going to be using IntelliJ. It'll be easier to follow along, and I guarantee once you started using it, you're not going to go back. Either way, let's create a new project, and I'm going to use Maven. Maven's just easy. If you want to use Gradle, that's fine. We're not bringing any dependencies in other than JUnit. So then I'm just going to call this Core Java Interview Questions. All of this code will be available for you on GitHub after I have finished. and then the artifact, we'll call it movie store, and then change it to 1.0, and then movie store, and then after IntelliJ is finished loading, oh, that's useless, let's close that. There we go. Okay, so we have our project here. Enable auto import, it's just easier. And so we have a blank project. Now this would be a good time to talk about what we're actually going to build. So movie store sounds fairly self-explanatory, but I'm going to go a little more into the detail of it. The idea is that we're going to have a collection of some movies. Then we're going to be able to search through them using a variety of different things. I'm going to tell you up front what all the fields we're going to search for. The way that we approach this in the interviews is we just say we have a movie store which is going to contain movies and we're going to search for them, and then we go through the first requirement. And so the first requirement is going to be to search by partial title. So if you have Harry Potter and you search for Harry, then that should return. Pretty simple, yep. We do not, for the purpose of this interview, need to worry about threading, databases, anything complicated like that, bringing in external libraries. It's a really simple core Java interview. Despite it being really simple, it trips an awful lot of people up. So we're going to go into it now. As discussed, the entirety of this we're going to be building using test-driven development. So we'll write our first test. I'll just create our first class just because it's easier to create the test this way. So we need a actual movie store. So nice and easy. And then we're going to create our first test. So in IntelliJ there is a great plugin called Enso, which I'll show you in a minute, and I can just use a simple keyboard shortcut to create a test for any class. So here we go. Now you can see here it's going, oh, I don't have IntelliJ. Sorry, I don't have JUnit. If you hit Alt Enter in IntelliJ, you just hit Alt Enter on anything grey, squiggly, or red, and it will bring in. They'll fix it for you. So add JUnit forward to the class path. In reality, you should probably add it as a Maven dependency if you're doing this seriously, but as it's just for a simple interview, I'm happy just to use the IntelliJ version. Replace qualified name with import to make it a bit neater. Now the first thing we have to do is to name our first test. Now, as I mentioned in the introduction, you have to create the simplest thing that you can. Let me just increase the font size on here. Okay, that should be nice and clear. So we need to name our first test, and we need to do the simplest thing possible. Now that is often the does nothing test. This is where you haven't set up any data or anything, you just call whatever method it is you're testing to make sure that nothing comes back. And it sounds a bit stupid, but it's a really good way of catching the zero case. So later on when we go on to add extra functionality, this test will cover in, when the code drops through and there are no results, for example. So let's say, so we want to have a movie store and we want to search by partial title. So to name the test, I will say returns no results when no titles partially match search. Now, yes, if this is looking pretty foreign to you in terms of the way of naming tests, this is a much better way of doing it than the traditional, from the old days of JUnit, where it would be like, you have to start it with test. You're better when you're writing test-driven development using the tests as a requirements document. So then when you have all these tests, it tells you exactly what the main class is doing. Now, this can be a bit wordy to read here, where it says return no results when no titles partially match search, blah, blah, blah. Which is why this Enso plugin I mentioned is so good, because it splits it up into sentences. So you can see here, returns no results when no titles partially match search. You are effectively building a requirements document. It's very clear what the test is actually testing, and it's just a really nice way of naming tests. Now, how do we implement this test? So we need to have a movie store, obviously, so let's create a movie store. And there we go. And then we said we want to have no titles match. So let's have no data in there at the moment. Let's just search for something. So movie store dot find by partial title, and let's search for, it doesn't actually matter, so I'll just put ABC for now. Now you'll see here this has gone red because that doesn't exist yet. That's easy enough in IntelliJ, Alt and Enter, create method find by partial title, and it creates that code for you. And this is partial title. Easy enough. Now we know that we want to have this return something. So you'll see here that I'm making lots of assumptions. And this is why I like using test-driven development, because we are building the structure of the code based entirely off actually using it from the test. So here we know that we want to have a list of movies results, which comes from this. Okay, so that's pretty cool. So we know we need a movie class of some sort. So again, Alt Enter, create class movie. We'll put in a model package. That's cool. IntelliJ needs to import results, and then it's complaining because at the moment this doesn't return anything. So we can say, okay, let's return it by movie. So if we go to the movie store now, you'll see that that is returning movie. Easy enough. And then we want to assert that results.size is 0. Now again, you're going, whoa, what's this crazy syntax, this assert that and is? And this is a library called Hamcrest, which already comes in as part of JUnit. Now, the reason I love Hamcrest is because it allows this really fluent API. It makes it a lot easier to read, to say, okay, I want to assert that the size of the results is 0. It's exactly what it says there. And it has such really, really nice library methods on there, so it gets a lot nicer when dealing with things like lists, and you'll see as we go on. You don't need to worry about it too much. You're going to learn it naturally as we go through these tests. For now, just give it a go, have a play, look at the website. So we have a real test here now. It's the no test. We've got no data in there. We're searching for something and we want the results to be 0. So let's give that a run. Having a little build of it, and the test is failing because we have a null pointer exception. Easy enough. So we can go to movie store. This is null. Now remember, in the red-green refactor, we've got a failing test now. That's awesome. We do not touch the test. That's good. We just touch the production code. So how do we get this to work? Now, I've mentioned that I want to talk about how candidates actually respond when we're doing this. A lot of people at this point will try and implement the whole thing and get the functionality correct. That is wrong. You're doing the minimum amount to make the test pass. In this case, we're expecting an empty list. So let's just create a new, let's do linked list. Doesn't really matter. So we're not using the partial title as being passed in. We're not putting any functionality in. But you should see here that the test passes. Awesome. You've now just written your first TDD test and your first TDD code. And one of the things I love about it is when you get that green, you get just a little serotonin release in your head, which makes it a lot more exciting as a developer because you've got rapid feedback. You're writing code, you're making it pass, as opposed to having to do it as this big, long spree of running huge chunks of code and then waiting until the end to see if it works. You get this little repeated feedback to say, yep, you got a bit more functionality working, and it's a really nice way of doing it. So you've written your first test. It's the easy test. We now need to write something else. So let's copy this test. Now, interestingly, candidates often get scared of this idea of copying and pasting. Traditionally, copy and paste is viewed as bad, but it's okay in this scenario. Let's just get the test going and then you can refactor afterwards. That's the third stage of the cycle, red, green, refactor. If after this we see there's obvious duplicate code, we can pull that out, and that's absolutely no problem. So we need to name this. So let's say we actually want to return a result. So finds a movie when title is partially matched. Makes sense. Again, you can see with Enso, nice and easy. So we have to actually add some data now. That's easy enough. So let's add what should we do? Harry Potter. Now you'll be like, whoa, you've added this add method, but it's not there. What are you doing? Again, this is why I like using TDD, because I know this is kind of what shape I would like that API to be in if I'm using it. So I'm now going to just do create method add. That's fine. We want it to be void, and then movie. Although actually, this is slightly wrong because we said we want to return it as movie. So let's create a new movie. You're like, okay, so there's no constructor at the moment. Easy enough. We now have a movie with a title. You'll notice when I'm doing this, I'm doing the very bare minimum. So I'm not assigning title in movie to anything. I'm not doing any production code. When you're writing tests, you just write tests, and you do the minimum amount of production code to make yourself, make it usable. Let's change that first parameter to movie. So there we go. Let's add some more movies. What else do we like? Shawshank Redemption. How about Star Wars? And let's add a fourth one, Star Trek. Cool, nice and easy. So if we now search for partial title by Ari, that's the example I used before, we would expect the results to be 1. And now, so this is another area where I love Hamcrest. So results contains, and then we want to make sure the movie is Harry Potter. So let's extract this as a variable. Movie Harry Potter. So static import method. Sorry. So the reason why this isn't working is because actually we need to import Hamcrest. So you can go to the Maven repository and pull out whatever the latest version of Hamcrest all is, and then just pop that above JUnit. Hit save. We've hit auto import before, so it should come in. And now you can see static import. So you can match the .contains. So in Hamcrest now, this is assert that results contains Harry Potter. Nice and simple. So let's run that test. Cool, so that is failing as we would expect it to. So now we need to do the bare minimum to make this test pass. So let's go over to the movie store. And so we need to add movies to some sort of structure. So one of the things when I've been interviewing candidates is at this point they start to panic and they go, oh, we could be storing hundreds of thousands of books. We need to have a really efficient data structure. We need databases. Work to the requirements. At this point, what I would expect is for maybe you to ask me as the person interviewing you, okay, how many books are we expecting to store? And I'd say for this test, for the purpose of this interview, I'm only caring about, 5, 6 movies, maybe 100 in theory, and that should instantly then say to you, okay, I should not be eagerly optimizing this. I can easily search through 100 list items, so we can just store it in a list. It's not a problem at all. We aren't going to be doing any deletions or anything like that, so it doesn't really matter between array or linked list, but I would say let's go for a linked list. So let's do linked list of movies. Movies equals new linked list. That should just be list, not linked list. So cool, and so now all we need to do is do movies.add. Now we add movie in. Cool. So we need to actually have a solution of some sort here. But again, we can make this much easier than the full solution. So let's loop through that list of movies. And then what we're trying to do is find a partial title match. So if we say if movie.title.contains partial title. Now again, you're going, whoa, what's this title thing? This is just how I like to write. Create the method you want and then let IntelliJ do the hard work for you. Title is a string. And that's fine. We'll come back to that in a minute. So if it does contain the partial title. What do we want it to do? In reality, the full solution to this is going to add it to a result list, but we said do the simplest thing possible to make the test pass. In this case, that is just returning the first one we see, because there are no other, there's only one thing that we're checking for. So return as list movie. We don't need to continue searching through the list at all. That will make the test pass. Now, as mentioned, we need to fix this up, which shouldn't be hard. Create field, title, and then that will return title. Now, for me, I think this should now work. So let's give it a whirl. It does. Now we also need to make sure that the first test works. So let's run all of them. There we go. We have a green test. And as you know, the functionality it's still not right, but we are writing test cases now that ensure everything is covered. And we're ensuring that we write better test cases. For the next test, I would suggest we don't in fact write another test. We fix this one, because obviously it's not good enough. So let's change it to finds movies when titles are partially matched. So we're now looking for multiple ones. So this would make sense then to use, well, we could use star, but one of the problems is, should this be case sensitive or not? As a candidate, I would expect you to have asked me that, because this is how we're trying to figure out all the requirements. So I'm going to say that it should be case insensitive. So I'm going to change this to Star Trek. And then if we search for tar, we would expect that the results.size to be 2. And then we want it to contain Star Wars and Star Trek. So we need to create those. So Star Wars and Star Trek. And so if I just move these up to separate that, there we go. Sorry, there we go, done that wrong. So we should check that this contains Star Trek and Star Wars. Now, do we care about the order? I would say not really, so I'm going to change this to be contains in any order. It's another just handy hamcraft. So if we run that, we see that it's failing, which is good. Now, before we dive into making this test pass, I'd just like to briefly talk about, you'll see while I'm doing this, I'm using tons and tons of shortcuts, which is because IntelliJ rocks, yes. But one of the things that as an interviewer I'm looking for is that you are able to handle your IDE. And that means being able to use shortcuts, that means being able to do refactoring quickly. I often see candidates coming in who really struggle, who are manually doing copy and paste, manually doing lots of typing. And that shows to me that you haven't attempted to learn your craft properly. You're spending 6, 7, 8 hours a day at your IDE programming. You should be learning how to use it as best and most efficiently as possible. So before if you have an interview like this, please just spend a bit of time learning. Hopefully you're learning from this as well, the sort of shortcuts that are available. If we see someone that's proficient with their IDE, it instantly boosts them a lot up, because I respect what they're doing as a programmer. So there's just a little tip for you. Let's now look at making the solution for this. So we know where the problem here is, obviously. It's that we're just returning 1. So let's have a result list. List movie result equals new linked list, and then now we will do result dot add movie. Easy peasy, right? The other thing to bear in mind, because this still isn't going to run, is because we are doing case insensitivity. Cool. So we need to change that to result.title. to uppercase. Watch title to uppercase. Not a particularly hard thing, but again, I've seen a number of candidates who get flummoxed at this. They're not sure how to do it, or they oh, this seems like a really amateur way of doing it. Don't worry about it. As I do TDD, we're doing the minimum amount to get the test to pass. This is a perfectly valid solution in my opinion. I'm going to run this, and you're going to see that it still isn't going to pass, even though that code is right. And that's because we are not returning at this point the result set. We're just returning this new linked list. So let's change that to return result. But it's one of the things like this. This is why I love TDD, because it catches silly little errors like that, which are so easy to make. So let's run all 3 tests now. Bazinga! Everything is working. Yep, yes, we've only got 2 tests still. So that's cool, and that to me looks like a pretty decent solution, We have a nice easy for loop. There's no reason not to have a for loop. We have the line where it does the check. And we've got a pretty comprehensive test here. Now, some of you might be saying, well, what about null checks? People seem to get very hung up on null checks. One of the things we say at the start of the interview is, I will agree not to pass nulls if you will agree not to pass nulls. This isn't an API that we're developing for external, where we expect that the data could come in mangled and horrible. This is something that we're saying would be used as an internal system. And if you're working internally, you should not be passing nulls around. That's terrible Java programming. It's a reason why things like optional exist these days. But I'm saying, for the purpose of this, let's all agree, no nulls. Data coming in is accurate and okay. Nice and easy. So, with that in mind, we should start our next test. Now, for the next test, I'm going to say that we will do search for movie by director. So we need to create that test. Now, what you could easily do here, and what people do, and it's absolutely fine, is copy this and then paste it, and then start writing your next test. But you'll see here instantly that we've got a lot of duplicate information, and it's going to start getting messy when we introduce new things. It makes sense, given the nature of what we're building, that this could live elsewhere, particularly in a setup. So let's move all these to fields. Now this, again, when I talk about the management and being good at your IDE, this is a big thing for me, because a lot of people here will start doing lots of copy and paste, lots of messy things. Should not be hard. It's easy enough to do move to a field declaration. Again. Nice and easy to do. And then movie store we also can have as a field. So these are all now up here and accessible to all the tests. This we just need to move to a setup method. So if we do that and then generate a setup method, paste, there we go. So now every time each test runs, it will generate our data set for us up there, and it means we don't have to do it in each and every one. Much easier. So let's now look at creating our test. So we now want to do find movies when title exactly matches. Oh, not when title, sorry. When director exactly matches. So you'll see again, if I bring up Enso, you can see we're starting to get an idea. One of the things that's missing here though, so we've got partially match. We mentioned about case sensitivity, so we can change this to be case insensitive. And then you can put case sensitive here if you want. I think for exactly match, that's fairly obvious. So movie store.find by director, and we'll have the director Schwimmer. Would help if I could spell. And so let's create this method, list of movies, string director. Now, we haven't got that data yet, so we need to introduce that here. Let me just create this into a field as well. And change the name to Shawshank. So just neaten it up a little. There we go. So we need to add this new data in here for the director. How do we go about that? Now, this is one of my big bugbears, because sometimes you'll get people who will go to the movie class and then they'll go, okay, I need to go string direct, and they'll do all this, and it takes absolutely ages with them having to manually fill it in. Your IDE can handle the addition of parameters really easily. So let's, for the sake of argument, say Star Wars was directed by Schwimmer, because I can never remember the director's names, although it was obviously Abrams. You've got a big red squiggly here. Alt-Enter. Add string as second parameter to movie, and then it automatically defaults the value so everyone will be Schwimmer. Hit Refactor. And look, everything's already done. Brilliant. Much, much easier. We can change the data set here. So let's change that to be Rowling and Shawshank to be Bob. And we're done. That's so easy, but I've seen people take upwards of 15 minutes making that refactor happen because they're manually typing things. Anyway, so we have Schwimmer. We've said again that there will be 2 results here. In fact, let's make it to be a third one, just for extra data set. So let's have one more film, which we'll call Take That, which was directed by Gary Barlow. Change the name of that to Take That. Make sure it's added to here. Cool. And sorry, let's make that by Schwimmer as well, actually. Just like to vary the amount of results that we're searching for, because it can help just to catch weird edge cases. And then we want to make sure it contains in it any order: Star Trek, Star Wars, and Take That. Perfect. Run the test. Oh, and it's failed. Unsurprisingly, as in the movie store, it doesn't do anything yet. So let's implement this. Now, the minimum for this one, you know, because we've done something very similar, I've not brought it from the ground up. It's basically the same as find by partial title. So let's copy find by partial title. And then we know this is the line which is different. The rest of it's just looping through, adding a result. Easy peasy. So movie.director.equals, because we want exact match. Oh, sorry, that should be a method. Director. Create that method. String does come up with some weird options sometimes. There we go. And then this should say director, not Schwimmer. That was my mistake from before. Create field for it. And then director should return that. Oh. There we go, that's fixed. It's dumb to have 2 versions of string. Anyway, so we have a solution here, which, you know, exact match looks good to me. Let's run that. Awesome. We have a nice green passing test. As you can see, it's, you know, this code is pretty clean. It's pretty obvious what it's doing. We have our ENSO, which clearly shows what's going on. Let's make it the next one a little bit harder. So now we're going to do finds movies when year is, sorry, when finds movies when release year is between 2 values. So we'll do find by release year, and then let's say 1999 to 2002. So all movies released between those years, we should be able to find it. So from 2. Now again, we're pretty good at this now, so we know we need to add a release year. So let's say Harry Potter was released in 2000. Add into the third parameter, refactor, everything's 2000. So let's say we're going to return 2 values again. No, 3 values. So the question is here, you have edge cases. As a candidate, I would expect you to be like, oh, if it falls on 1999, should it be included or should it not be? So I'm going to say for the sake of this argument that it shouldn't be. So 99, 2002, not included. So it's only films in 2000 and 2001. So let's put Shawshank as 2001. So we know those two should. 1999 we know should not. 2002 should not. And 2010. So you've covered your edge cases here, which is the important thing to do with this sort of test, and that's what I will be looking for you to come up with. So if we say, so it's Harry Potter and Shawshank, we said. So if we run that, we'll see a failure is expected, which is cool. And you can see what's happening here. This, we're building up to a crescendo here. It's copy and paste time again. This time, so we want if the movie.release year is greater than from, and movie.release year is less than 2. Okay, so we can see what's happening here. Sorry that this is probably a little bit repetitive, but it's all building up to something good, I promise you. Okay, so now if we go to the movie store test, let's run everything and make sure. Because remember, every time you make a test pass, you should run all of your tests to make sure you're not broken anything else. And so here we've now got, a good solution. So from my perspective as the interviewer, I'm comfortable we've covered all the requirements that we want to at this point, and this is pretty clean code. One of the the big problems that tends to happen is people copy the initialization of the data over and over and over and over again through this. As long as you pulled it up here and you know how to refactor, that's good. But as discussed in the wonderful circle of test-driven development, this is red, green, refactor. We've done red, we've done green repeatedly, and it's time to refactor. And hopefully, because what I would say to the candidate at this point is, okay, what do you think of this code? Is it good? Is it bad? Do you like it? And I would be looking for you to look at this code and go, well, we've copied and pasted over and over and over and over again. As you know, so if we take this, copy it, and then take this, and then do compare with clipboard, you can see it's just this one line that changes, and it's the same for all of them. So how can we pull this out? It shouldn't look like this. We should be able to condense this code down quite a lot. Now, I want you to stop the video, start looking, and for you to try and figure this out. This is the big crescendo ending at the end of the interview where people struggle. People want to, for example, use switch statements. Switch statements are not good object orientation, and they're also ridiculously difficult to do. This is why, as an interviewer, I've added this one in with integers, because and with multiple ones, because it makes it really hard to kind of do that idea of a switch statement. So how can you do this? What is an object-oriented solution? Okay, I hope you've had a think, and now we'll take a look. So we know that there is something that needs to happen here, right? The rest of the code is the same, so this is what's changing. So it's a Boolean statement here because it's part of an if statement. So let's take a nice easy one, the exact match. Oops, excuse me. So we know that there needs to be an interface or something here. What could that look like? The only thing that's changing in every loop is the movie, so we want to make sure that that gets passed in. So let's create this interface here. Let's call it a predicate. And it's going to have one thing on it. So we know we need to return a Boolean. And we want to check that something matches. And that thing is a movie. Okay? So again, let's look at this. In each loop, we want a Boolean here. Director stays the same throughout. That's what we're comparing it to. This is all that changes. So if I create this predicate interface, what I can then do here is if I cut this, I can do a new predicate and check if that matches director. And I will implement the method. So I'm just using an anonymous inner class here. Director needs to become final. And then, oops, I've used the wrong thing here, sorry. Matches movie. So this might look a bit complicated now, but it's going to make things a lot easier because now the rest of the code is reusable. Let's make this a bit clearer. If I do this again, so here, this is our variable bit, the big if statement. So if I create a new predicate, matches movie, and then implement that method to return based on what we just said. Final one. Oh, sorry, hit the wrong button there. So now if we new predicate dot matches movie, and this time the implementation is, there we go, variables become final. So just as a point of reference, let me just prove that all the tests are still passing at this point. We have not changed any functionality. As discussed earlier, it's pivotally important that when you're refactoring production code, you do not change the tests. When you're refactoring tests, you do not change production code. So you see, we're still the exact same here. Every loop we're just creating a new predicate which does the same matching. But now, so here's where the magic happens. If we pull this predicate out, predicate, move these to the top, and we'll do this for all of them. You will see that all of the code matches. So if I copied that one and compare it to this one, edit, compare with clipboard, it's the same. Sorry, I forgot to copy the extra line. But everything matches, which means in IntelliJ you can now do this lovely thing where I create a method called findBy, and it takes a predicate, hit OK, and IntelliJ has detected there's two other bits of code which are exactly the same. And I have replaced them all. So this is your findBy method, so this is the piece of code that we were repeating over and over again. And then here we have findBy release year, findBy partial title, findBy director, where all that we're having to change is this line here. Now hopefully if you're familiar with Java 8, you're probably screaming by this point, but you know, this should be much cleaner, much easier. You're only on Java 7, so let's upgrade our Maven to Java 8. Now there's just a simple bit of code that you need to whack in from here. Feel free to just steal it from mine. This just tells Maven, please use Java 8. So now you'll see everything's gone grey squiggly here because we have a class which has one method only, and in Java 8 we can now abbreviate that to being an anonymous function. So if we do replace with lambda, wow, look at that. So then our code becomes much easier, and we can go one step further and inline. And so we have some nice, lovely, clean code here. You can find by, and then you just pass in whatever your function is to do it. So there was a lot to take in there during that final section of the refactor. Go back, watch it a few times. This is showing that you have a good core understanding of Java and patterns. This isn't easy if you've not seen it before, but when we're interviewing, we understand that. If it's a junior person, we really understand it and we'll help you work through the solution to get here. If you're senior, we'd expect you more to be able to just get on with this and do it. The important thing when you're doing interviews like this is that you speak out loud. If you aren't telling us what you're doing or what your thoughts are, we don't know if you've got stuck or if you're just having a think. And the interviewer can help you, and that's not an indictment. It doesn't mean you failed. It's totally okay. But don't go too far, because you don't need to say, I am now making a list, because no one needs to know that. We know how to program Java. We don't need to have you tell us how to do Java, just your thought process and your thinking patterns. I really hope you've enjoyed this course. If you have any questions, any thoughts, feel free to contact me directly. My email is hello@corejavainterviewquestions.com. I will answer anything. If you feel any parts of this course need expanding on, extending, I'm more than happy to do that. I'm all ears. And let me know what you thought of the course and what your favourite parts were. Thanks very much.